For lesson 3, we'll go ahead and we'll actually start using the nesting tool. Now the difference between lesson 2 and lesson 3 is I went through and I created patterns for the rest of the components that were alike, just like you saw in lesson 2. Also unfolded these pans and put the notches in. So from here, we're now ready to go ahead and start nesting. When I get everything the way I set the way that I want, I generally always save it. That's just a habit that I've had for years and years and years. So from here, we'll go ahead and we'll actually do create nest job. So it'll take just a second and it'll fire up here. As you can see, it's actually going through and unfolding everything. Because we already have sheet metal stuff laid out in here, it just went and did it automatically, real easy. Now there's a couple things to look at in here. For one, you can see that everything gets sorted by thickness, so you can scroll through the different thicknesses. We also have different material types. This does become important because if they are different materials in SolidWorks, it will nest them on separate sheets because it does understand the difference in thickness and the difference in material. So if we had some that was hot rolled, some that was cold rolled, some that was aluminum, it would separate everything out on its own right. Now, where this becomes a little interesting is you put in your part-to-part distance, which generally for part-to-part distance I use the minimum distance of the material I got for nesting. So if I have 1/2 inch between parts, I would put a 1/2 inch. And then part to sheet distance is how far in off of the corner of the part it's going to be. Now, we have parts that are 120 inches long. We get our sheets at 120 inches. So our sheets will generally come in 120 1/4. So we cannot have a 120 inch part with a 1/2 inch all the way around it from the edge of the sheet and make it fit. CAMWorks Nesting will automatically know if it doesn't fit on the sheet and it will not nest it. So on parts that are 120 inches long, I will generally make it 5/16 in, or I may go just 30 thousandths in. It just really depends upon the part and what our steel is coming in. Now, if we're doing a bunch of parts that are shorter or small parts, then I will generally always use a 1/2 inch in from the edge. That eliminates any curve or bow in the sheets or any discrepancies on how the material gets loaded. For these parts, because it's 10 foot, we'll just do 30 thousandths in. And then when we come over here to our sheet data, we'll use a custom size, which is 120.25 long, and then we'll do 60 inches wide. Now our sheets generally come in at 60 1/4, which gives us a little bit of room in our Y direction, but I generally try to keep it at 60. For here, we'll leave the quantity at 20. If I know I only have one sheet of material in stock, then I'll put in 1 and it'll try to nest it the best it can on 1. So we'll go ahead and hit add a sheet for 16 gauge, add a sheet for 1/2 inch, add a sheet for 1/4, add a sheet for 3/16, and now we have all the material accounted for here. If you had like a twin router machine, you could set up single head, multi-head. We actually just have a single laser. So from here, we'll go ahead and hit OK, and CAMWorks will go through and start doing the nesting. Now, you can do fast nesting or optimal. Generally, for what we do, where it's mostly rectangles, what I found is fast nesting works well. If we're doing contract work where we have a bunch of unique shapes, then we'll do optimal nesting because it does save quite a bit of material going that way, just because it'll nest it a little bit tighter. For rectangles, it's pretty simplistic on how to nest. once it completes the nest, you can have it bring up the report for you. This came up on my other monitor. So from here, you can see here's the nested quantities we were after. Here are the total quantities that it nested. It's always good to check these numbers, because if you typed in the wrong number or the part was too big for the sheet, it'll actually give a 0 in the nested quantity, and it'll tell you that you're missing parts. You can see here there's 8 unique parts that were made because we used the patterning command, but it's actually going to make 38 parts for this one section. And it gives you an overall utilization. This number will vary depending upon how many parts and what gets left on the sheet. You can see for each sheet the percentages of utilization that we're using. Some of them are pretty small, like I know this one is the 1/2 inch part. So it's always good to check this report that comes up from CAMWorks Nesting. And then once we have this, we now have our base nested sheet. And this will conclude this lesson.